Hello, everyone. Welcome back to College Algebra. This is the final section of Chapter 1 Properties of Real Numbers, self titled Properties of Real Numbers. I wanted to end this section or chapter on the actual properties that we use when solving algebraic equations or expressions. These properties, while quite often you won't think of them while using them, they are very important nevertheless, and they're used in many different ways in mathematics. This thing is in the way. They're used many different ways, and it's important that we understand their unique properties. So, with that said, this final section, section 5, properties of real numbers, we are going to begin with the inverse properties. So, we have two sections or two types of properties or two classes, I would say. You got two classes. I'm going to write class 1 and class 2. And most of these properties will have a unique aspect in each class. I believe there's one property that will only be in one class. So, class 1 is addition. Class 2 is going to be multiplication. Cool? So, just keep that in mind. This isn't something formal or official. This is me explaining it in a way where I think it will be helpful. So, I'm instead of writing the plus sign in the multiply sign, I'm going to go ahead and write addition and multiplication. Okay, so properties of real number. The first property we are going to talk about is your inverse property. So I'm going to write inverse. Let's use orange. Inverse property. All right. What does the inverse property mean when applied to addition? And what does the inverse property mean when applied to multiplication? For addition, class A or class 1 or case. I think case would be a better word. I'm going to write case. Case 1, case 2. So, with case 1 addition, the inverse property is talking about the inverse of a number. How do you get the inverse or its opposites? So we talked about this a little bit in some of our previous episodes. The inverse of addition we know is subtraction, and the inverse of multiplication gives us a negative number, or if it's the inverse of a negative, a positive number. So with addition, what the inverse property means for addition is a little bit different than what it means for multiplication. I'll explain. So we have A, okay? Remember, we're using variables. When you add a negative A, you end up with 0. The inverse property of addition states that any number added to its inverse equals 0. Any number added to its inverse equals 0. In numerical terms, say we have 13 plus a negative 13. This means we have 13 minus 13 equals 0. For the case 2, multiplication, the inverse property of multiplication. When we have a number multiplied by its inverse, you don't get 0. You get 1. How? We talked about this a few times. Let's say we have A, and then we going to multiply A by its inverse. What is the inverse of A? We talked about it. It's division. The inverse of multiplication is division. So the inverse of A would be 1 over A. This becomes A divided by A, and any number divided by itself becomes 1. So, inverse property of addition, if we add the inverse of a number, it becomes 0. Inverse property of multiplication, when we multiply a number by its inverse, it becomes 1. So there's a slight discrepancy about what happens, but we understand it as meaning it is the addition or multiplication of an inverse number. The identity property. The identity property. Now we have an identity property for both addition and multiplication as well. What do we mean by identity? When we apply the identity property to both addition and multiplication, what we find is that the number being affected does not change. So, if we're using addition, what this states is that any number plus 0 equals that same number. It does not change. So any number plus 0 equals A. So A plus 0 equals A. So for example, say we got 3 plus 0, we stay with 3. The number doesn't change. In other words, it keeps its identity. This 3 keeps its identity and stays the same. That is the identity property of addition. Very, very similar for multiplication. Check this out. Any number, I meant to use, I don't know why on orange. Any number times 1 equals that same number. For example, if we have 3 times 1, the answer or the product is still 3. It does not change. The 3 keeps its identity. And now the identity case or the identity property of multiplication is used constantly and we don't even realize it. For example, last video I used an example to express terms and algebraic expressions, and one of those terms I believe was don't do that in the middle, was x squared. X squared times 1 is still x squared, so we don't have to write the coefficient of 1 in front of it because it equals itself. So every time you see a variable by itself, it's actually using the identity property of multiplication. Next, the commutative property. I said that with strong T's, huh? The commutative property. Both addition and multiplication has a case in the commutative property. So all the commutative property means for addition means that when we have A plus B, that equals the same thing as B plus A. In other words, if we have 2 plus 3, that still equals 3 plus 2. You can write it backwards if you want. Sometimes that actually helps when trying to solve a problem. So this commutative property is a great help in solving problems sometimes. Commutative, all it really means is that when you communicate, a communication is a two-way conversation, right? If me and you are talking, we got to talk together. We go back and forth. Same thing with this. A and B can be swapped both ways. They go back and forth. You could swap them 2 plus 3 or 3 plus 2. The same exact thing applies to multiplication. If we have, oh wow, that was a lag, 2 times 4, that is the same as saying 4 times 2. It doesn't change. Or using the algebraic letters, A times B equals B times A. It doesn't change one bit at all. It is commutative. It goes both ways. Associative property. The associative property also has a case for both addition and multiplication. I have found that sometimes when doing more difficult problems, the associative property has come to my rescue without even knowing that that was actually being used. A lot of times it is quite helpful. All of these are helpful. Sometimes these are properties that you don't necessarily have to use, but using them helps a lot. So the associative property of addition, what this states is that when you have numbers being added together in parentheses and numbers being added on the outside, you can shift those around. For example, say we have a plus b in parentheses and c on the outside being added to it. It's the same thing as saying a plus and inside parentheses b plus c. I shifted, in other words, I swapped the a and the c from the inside and outside of the parentheses, and it still equals the same thing. For example, say we have in parentheses 3 plus 5 plus 2 outside the parentheses. This is the same thing as saying 3 plus, in parentheses, 5 plus 2. And we could try it right now just to see. 3 plus 5 is 8 plus 2. 3 plus 5, 6, 7. 8 plus 2 is 10. 7 plus 3 is 10. It equals. It's the same thing. Ain't that cool? And the same thing goes for multiplication. And this will tie into the next and final property that I'm going to introduce. So for multiplication, say we have in parentheses a times b times c outside of parentheses. It's the same thing as saying a times b times c in parentheses. And so we could swap out some math and show you real quick. Say we have 2 times 3 times 4. That's the same thing as saying 2. Oops, I wrote an A. 2 times 3 times 4. And we can solve this real quick. 6 times 4, 2 times 12. 6 and 4 is 24. 12 and 2 is 24. It equals the same thing. So the associated property of multiplication, not addition, multiplication ties into a next and final property. And I'll explain what I mean in a second. The distributive property only applies to multiplication, does not work with addition. Why does this work with multiplication? Well, if you remember, when we did the associative property, I'm going to write that right here real quick. Associative for multiplication. We had A, B, C equals C, or A, B, C. What we did is a type of factoring out also, because we only have a single term here. So this here, AB times C, is same thing as saying ABC, ABC, and then we factored out the A, B, C. We haven't talked about factoring much yet, but we will have dedicated lessons to all of those subjects in factoring. And there won't be too much longer. So this is the type of factoring that we do. Factoring. It's a very highly used tool that we use in algebra. And you need to master it. You will have to learn to master factoring. It's hard and frustrating at first because it's a strange concept. But you master it, it will become one of your best friends in math. So this associative property, what we did is we had A times B times C equals A times B times C, and we proved it by saying, okay, let's since this both equals all 3 times together, we could just put the C in and put the A out, and we still end up with the same answer. What that was is a type of distribution. The distributive property states that when you have a number on the outside of parentheses being applied or multiplied to the inside number of a parenthesis, you multiply it inward. So if we have I'm going to start with the simple one first. If we have A times B, let's do BC, just to keep in line with what we did with associative. That equals A times B times C. Now, distributive property covers another part of understanding. What if they are two terms inside the parentheses? Let's say we have A times B plus C. Now we have two terms. We have a B and we have a C. How does this work? You multiply what's on the outside to all the terms on the inside. This A gets applied or multiplied to the B, and it gets multiplied to the C. So A times B plus C is equal to AB plus AC. For example, say A equals 2, and we have 3 plus 4. A times 3 plus 4. What we have is what we can do. We can do this two ways. We can do it the old way that we learned, through the parentheses first. We can do 2 times 7, which equals 14. Or you can apply the distribution rule. It only works when there is a factor of a number outside of parentheses being multiplied. So if this was a plus, it wouldn't work. If it was a negative, a minus, it wouldn't work. It'll only work with multiplication and by extension division by the multiplying inverse. But we'll cover that another day. So 2 times 3 plus 4. This would end up being 2 times 3 plus 2 times 4. Does this equal 14 just like it did with the previous way we tried it? Let's find out. We have 2 times 3 is 6. That's a 3, not a 6. 6 plus 2 times 4 is 8. And 8 plus 6 equals 14. It's the same. You can multiply the number on the outside to all the parts on the inside. That is called the distributive property. And it works the opposite way. I'm going to erase this side right here on the associative side. Check this out. Say, for example, I'm going to erase this too. And I'm gonna rewrite our rule so we can remember. Okay, let's say we have a large number and you don't feel like adding large numbers. And I'm not gonna put a large number, but let's say we have 12 plus 14. Now, you could probably do this in your head, but maybe you just woke up. Maybe you don't really want to do the math. I don't know. I'm just trying to give an example and not seeing the perfect opportunity to do something. Let's go backwards from when we did the distribution. Remember, A times B plus A times C is equal to A times B plus C. Let's find a factor that a singular factor when multiplied two numbers to two separate numbers equals 12 and 14. What numbers, in other words, let's find numbers that both multiply to make these numbers. For 12, we got 1, 2, 3, 4, and 6. How so? 1 time and 12. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. There's our factors. And for this 14, we have 1, 2, 7, and 14. Why did I draw 2 ones? 14. Because 1 times 14 equals 14, and 2 times 7 equals 14. I see one match that we can utilize to make this little expression simpler. I see a 2 in both factors for 12 and 14. So 2 times 6 equals 12. So we have 2 times 6 plus 2 times 7 equals 14, right? Now let's go backwards. 2 times 6 plus 7. We went backwards. It works both ways. It's a very short video. I didn't want to spend too much time on it because I think that most of us are going to learn these properties by using them in the upcoming lessons. My next lesson will be on the exponents. Now you might think we just did exponents. No, we just introduced exponents. Now we are going to cover the rules and laws regulating how exponents are used in algebra. And we're going to get more advanced and more complex as time goes on, because I want to be able to teach calculus on here, but I don't feel like I'll be able to do it if I don't introduce everything. So just take your time, cover a few sections for exponents and then radicals, and then we'll move on to factoring after that. I hope you all enjoyed this video. Let me know if you learned something. Let me know if you enjoyed it. Got tips for me? Leave them in the comments. Let me know what y'all think. I'll see y'all next time.